All right, we made it to the last page of our review. Number 26 is a lot like number 25. It says, what is the cosine of theta if sine of theta is equal to negative 16 over 20 and theta, our angle, is in quadrant 3? So we're going to approach this the same way we did the last one. We're going to draw the angle first. It's in quadrant 3, so here's 1, 2, here's quadrant 3. The angle comes off of the x-axis. I'm going to go ahead and just draw in. I don't know where the angle is, so I'm just going to put it there. This is where theta is. We want to create a right triangle to the x-axis with a vertical line. There's our right angle. And when they tell us that the sine is negative 16 over 20, we know that sine is opposite over hypotenuse. So they are giving us the opposite and the hypotenuse sides of this triangle. So our hypotenuse is right here. This is the opposite side, and this is the adjacent side. So if we just put our sides in there, the opposite is a negative 16. The hypotenuse is 20. We need to find the adjacent side. So we can do Pythagorean theorem. A squared plus negative 16 squared equals 20 squared. When we do that work to solve, we end up with A equal to 12. All right, so I'm going to put this 12 into the picture, but we want to just take note that we are going to the left 12 units, so that will be a negative 12. All right, now that we have our triangle, we can evaluate the cosine of our angle. So we think about SOHCAHTOA. The cosine is the adjacent side over the hypotenuse. So adjacent is negative 12 over the hypotenuse 20. But we do want to reduce that. So in the end, cosine of our angle, we can divide both of those by 4 and we get negative 3 over 5. All right, last two problems. Just a heads up, these are probably going to be more, not complicated, but just a little more algebra work with, like, you'll see what I mean. Hopefully it won't feel like a lot, but if you've been going along with this whole video, I'm going to pull from some things we've already talked about in more detail in other problems. So this will go make it a little bit faster. But we have to find the secant, cosecant, and cotangent for each angle. So those are our reciprocal trig functions. So we want to draw our angle, create the right triangle, figure out the sides of the right triangle so we can do sine, cosine, tangent, but we're going to do the reciprocals of those. All right, so pi over 4, we take pi, the top half, we divide it into 4 equal parts. 1, 2, 3, 4. Pi over 4 is just one of those, so this is where your pi over 4 angle is. We need to create the right triangle so we can do our trigonometry. So we draw a vertical line to the x-axis. Now pi over 4, we want to know what this angle is. Pi is the same thing as 180. So if we took pi and divided it into 4 equal parts, we can take 180 and divide it into 4 equal parts, and we get 45. So this is a 45-degree angle right there inside the triangle. So it's a 45, 45, 90 triangle. We've had a couple of these already, so we know the hypotenuse is 1 and our legs are both root 2 over 2. Let's just double check the signs. We're going to the right, so that will be positive, and then we're going up, so that will also be positive. Hypotenuse always positive. Let's go ahead and label. We have our hypotenuse, opposite, and adjacent sides. Okay, now we are ready to evaluate secant, cosecant, and cotangent. I'm going to start with the cosecant. That is abbreviated as CSC, so cosecant of pi over 4. Um, Cosecant is the reciprocal function for sine. So sine and cosecant go together. So if sine is opposite over hypotenuse, cosecant is hypotenuse over the opposite side. Now our hypotenuse is 1 and the opposite is root 2 over 2. So we just end up with a problem like this with a lot of like dividing by fractions. So this is where it's going to feel like extra work. What we do is we keep our 1. Instead of dividing by the fraction, we multiply it by the reciprocal, 2 over root 2. That gets us a 2 in the numerator, a root 2 in the denominator, and then we have to rationalize. We're going to multiply the numerator and denominator by a root 2 over 2. So we have 2 root 2 on the numerator. Denominator, square root of 2 times square root of 2 is 2. And now we have these 2's. This 2 right here is going to divide with this 2 right there, leaving us with just a square root of 2. All right, so the cosecant of pi over 4 is square root of 2. All right, next one, the secant of pi over 4. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. So the hypotenuse is 1, the adjacent side is root 2 over 2. And here's where we want to just recognize, oh, we just had this same fraction. So I know that this will simplify all the way down to a square root of 2. So we're going to borrow that work and just say we know that it's equal to a square root of 2. Cotangent of pi over 4. Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. So the adjacent is square root of 2 over 2. The opposite is square root of 2 over 2. And here we just have a value dividing by itself, so that will simplify to just a 1. Okay, last problem. 330 degrees. So we draw the angle. 330 degrees is going to be in the 4th quadrant because here's 90. Oh, I guess I could draw this out as I'm saying it. Here's 90, 180, 270. Now, if I were to go all the way back to the axis, that would be 360, but we only need to go to 330, so this is going to end 30 degrees shy of that axis. Okay, so we are going to create our triangle, connect to the x-axis with a vertical line. There's our right angle. This is our 330 degree angle, and then 30 more degrees would get us back up there. So this is a 30 degree angle right there. So we're looking at a 30, 60, 90 triangle. We're going to borrow from the unit circle, and our hypotenuse is 1. The short leg, which is opposite the 30, is half of the hypotenuse, so 1/2. And then the side opposite the 60 is the short leg times the root 3, which simplifies to, root 3 over 2. And then we got to check our signs. We're going to the right so that will be positive. We're going down, so this leg will be negative. So we're going to have a negative 1/2. All right, so let's find cosecant, secant, and tangent. So cosecant of 330 degrees is the reciprocal of sine. We just wrote that out on the last problem, so we know that it's going to be the hypotenuse over the opposite side. Hypotenuse is 1. Oh, let's label those. Here's our hypotenuse. This just makes it go a little faster. Here's the opposite side, and here is the adjacent side. Okay, so hypotenuse is 1 over the opposite is a negative 1/2. So again, we are going to have the dividing by a fraction. So instead of dividing by 1/2, the 1 will multiply by the reciprocal, negative 2 over 1. And 1 times a negative 2 over 1 is just a negative 2. So the cosecant of 330 degrees is negative 2. Secant of 330 degrees is the reciprocal of the cosine function. So this is going to be the hypotenuse over the adjacent side. Hypotenuse is 1, adjacent is root 3 over 2. To simplify, we're going to take our numerator 1 and multiply by the reciprocal 2 over root 3. So this is a 2 over root 3, but we can't leave that root 3 in the denominator, so we're going to rationalize, and we end up with a 2 root 3 in the numerator, and then the denominator, square root of 3 times square root of 3 is 3. And that cannot be simplified any further. So very last one, we have tangent of 330 degrees. Tangent is the reciprocal, not tangent, I meant to say cotangent. Cotangent of 330 degrees. That's the reciprocal of tangent, so it's going to be the adjacent side over the opposite. Adjacent is root 3 over 2. Opposite is negative 1/2. So when we divide the fractions, we keep the numerator, root 3 over 2, times the reciprocal of the denominator, so negative 2 over 1. We get a negative 2 root 2 in the numerator over 2 in the denominator. These 2's will divide to 1 or reduce to 1, so we end up with a negative square root of 2 for the cotangent. All right, there is our last problem on our trigonometry review. I hope this helped you feel more prepared with a little extra review for your test retake.